Now, welcome to this lesson. Now, the method or the lesson today is majorly on area approximation, but today I want us to go through examples, but this example will be specifically on using trapezoidal rule to work out the area of some irregular shapes. I'm going to provide two examples. One of them will be under the strips, and then the other one will be under ordinates, so that we see how we are supposed to work out those questions whenever we meet them. Now, the first question I'll be tackling is y equals to x squared. The range is x to 0 and x equals to 2. They are told to use 4 trapezia. So the question goes, find the area of the region that is bounded by the graph of the following equation, the x-axis and the indicated lines. So the first step that you're supposed to do there is to find the uniform height of each trapezium, and that one is gotten by taking the difference between the boundaries and then you divide by the number of trapezium. So it will be 2 minus 0 divided by 4, which for this case we get that the height h is a half. The second step, then we proceed on to tabulate a table so that we can find the ordinates of those trapezium. And this one is done as follows in this table. So what you are going to do, we'll start with the lower boundary, and then we keep on adding the height until we reach the upper boundary. So x will be on the range of 0, a half, 1, 1.5, and 2. Then we'll try to find those heights by using the function given, which is y is equals to x squared. So we substitute the values of x and then we get the values of y. By so doing that one, you get the first y is 0, the second one is a quarter, the third one is 1, the fourth one is 2.25, and the last y is 4. Now we can actually name these y's as the first one being y0, the second one being y1, which is a quarter, the third one, which is 1, being y2, y3 being 2.25, and y4 being 4. Now, recalling that area is given by a half multiplied by h, the sum of the first and the last height, and then twice the sum of the intermediate heights, then we can substitute the values from the table to have area equals to a half multiplied by the height, which is a half, the first and the last height, 0 plus 4, twice the remaining height, that is a quarter plus 1 plus 2.5. By so doing that one, using your calculator, we end up with 2.75 square units. To confirm that answer, we can actually decide to use the integral approach so that we can get the exact area by integrating that function from 0 to 2, and by so doing that one, we get that the exact area for that case is 2.667. Remember, we can get the exact area, or we can make our approximation nearer the exact area by using more trapezia. Remember this, the smaller the trapezium, the accurate your answer become. Now, the second example is y equals to x squared plus 2. The boundaries is from negative 2 to 2. And for this case, you are told to use 9 ordinates. Remember, if we are using 9 ordinates, then it means we have 8 strips. Then we proceed on to find the height of each strip. And that one can be gotten by taking the difference between the two, and then we divide by the number of strips. That is 2 minus 2 over 8, which give us 0.5, that being the height of each trapezium. Now we proceed on to tabulate the table so that we can find the ordinates as follows. Now we'll keep on adding again the height from negative 2 to negative 1.5, negative 1, then 0.5, negative 0, 0.5, 1, 1.5, and 2. Then we'll substitute the values of x to the given function, y equals to x squared plus 2, which by substituting, we get the values listed below x, and then we can actually name those heights as y0 being 6, y1 being 4.25, y2 being 3, y3 being 2.25, y4 being 2, y5 being 2.25, y6 being 3, y7 being 4.25, and the last height y8 being 6. Then we recall again the formula that we said for finding that one. Remember, we'll take y0 plus y7, y0 plus y8, and then the intermediate heights are actually summed and then multiplied by 2, because we said they appear twice. Substituting in the values from the table, we have that the area equals to the first and the last height, which is 6 plus 6, and then the intermediate height multiplied by 2, then summing them and multiplying by whatever that is outside, we get the correct answer being 13.5 square units. The same answer can also be confirmed by using the integral approach, by integrating that function and then substituting the intervals from -2 to 2, we get the correct answer being 13.33 or 13 and a third square units. So remember, the approximated answer is closer to the exact answer that is required, and this one can be achieved if we use more and more trapezium. I believe that these two examples have actually helped you to understand the approach of trapezoidal rule, and thank you for your time, and thank you for following up those videos. May God bless you, and follow me for more and more video on the same. Thank you, and God bless you.